Hi! In this video, I will show you how to use our gGAN code to predict the brain graph evolution trajectory from a single time point. This work is accepted as oral presentation at Prime Workshop held in MICCAI Conference 2020. So, first we will start with the installation of Anaconda. Second, we will install Pytorch and other packages we need to run our gGAN code. And finally, we will test our code on assimilated data. In this step, you will download the Anaconda from the following websites. The web page will appear like this. Choose the distribution dedicated for your operating system and click on the link to download it. For example, in my case, I downloaded Anaconda 3 for Windows as I have Windows operating system. Then, you need to create a Conda environment where you will install all packages you need. So, copy and paste this command in Anaconda prompt and specify the name of your environment and the Python version you want to use. Next, to install Pytorch, you first need to activate the environment you created by typing in Anaconda prompt the following command. Install Pytorch using these commands. In this example, we use Pytorch 140. If you don't use CUDA or use a different version, type CPU only instead of CUDA toolkit equals 10.2 or write your CUDA version instead of 10.2 and install Pytorch geometric following the instructions in this link. Also install Pytorch scatter and Pytorch sparse using these commands. If you don't have CUDA or you have a different version, you just can write CPU or your CUDA version instead of Q101. You also need to install Jupyter Notebook, NumPy, scikit-learn and SciPy packages. To do so, type in the terminal pip install and add the name of the package you need. Finally, clone our gGAN code from the following GitHub link. To prepare the data, you need to provide a set of brain graphs at baseline time point and the next time point. We denote the number of subjects as ns, baseline time point as t0, and next time point as t1. Next, you need to construct them as graphs of size nr times nr. nr denotes the number of regions. As final, there should be two matrices of size ns times nr times nr. To run gGAN on simulated data, first use the terminal to open Jupyter Notebook on your browser. Then go to the location of the gGAN folder that you downloaded from GitHub. Then create a Python file by clicking New. Run the command run demo.py. You need to input manually the number of subjects, number of regions, number of epochs, and number of folds when starting the demo. By the end of the execution, you will receive the predicted brain graphs at the corresponding time point as a matrix of size, number of testing subjects times number of features. For more details, you can check our YouTube video on Basira Lab channel, and you can check our code on GitHub by clicking on the link below.